So we're going to explore integrals of the type cosine nx cosine mx dx sine nx sine mx dx sine nx cosine mx. So same trig function, product of same trig function and product of mixed sine with cosine. Okay, before we start solving trig function of this form, let me remind you some formulas of the trig functions. So that is cosine x cosine y is equal 1/2 cosine x plus y plus cosine x minus y. Next, sine x sine y is equal 1/2 cosine x minus y minus cosine x plus y. Next, sine x cosine y is equal 1/2 sine x plus y plus sine x minus y. Okay, so first example is integral cosine 5x cosine 3x dx. Okay, let's open formula for product of two cosines. It's going to be equal 1/2 cosine 8x plus cosine 2x, right? 5x plus 3x, 5x minus 3x dx. And this is equal 1/2 integral cosine 8x dx plus 1/2 cosine 2x dx. So the fact that we have cosine 8x, cosine 2x, it tells us that we have to do substitution. And we are going to substitute 8x and 2x, right? So u is equal 8x and du is equal 8 dx. Okay, and let me do also the cosine 2x. So I substitute v is equal to x and dv is equal to dx. Okay, so from here, what do we have? We have 1/2 cosine u times, we need 8 dx, right? So therefore, Okay, as always, I'm trying to jump and then slow down myself. It's going to be cosine 8x, and then I need to squeeze in 8 and divide by 8 also accordingly to keep the balance, and time here dx, all right, and then plus 1/2 integral. We have cosine 2x, and we need 2 dx, which is going to be times 2, and divide by 2 here also, not to disbalance the integral, and we have 2 dx. Okay, from here we are going to get 1/16 integral cosine u du plus 1/4 integral cosine v dv. And the answer, we are going to get 1/16 sine 8x plus 1/4 sine 2x plus c. Okay. Similar way, we can solve the sine times sine, cosine times sine. So it's a very easy way. So I'm not going to bring more example because it's clear. It's very easy to do. But subject of my attention, of my interest, is integrals of type sine x power n times cosine x of power m dx. Okay, so here we are going to look into a couple of cases. So first of all, we are going to look into exponent n and m, n and m, where n or m or both okay, or both are odd. Okay, so therefore, let's say we take let m is odd. Hence, m is equal 2k plus 1. That's a formula for odd one, right? 2k will be formula for even number. 2k plus 1, it's going to be formula for odd one, right? And for the integrals of this form, sine x to power n, cosine x to power m, we are going to substitute sine x with t. And from here, dt, it's going to be cosine x dx, yes? All right. Then, integral sine x of power n times cosine x of power m dx, it's going to be equal integral sine x to power n times cosine to power to k plus 1 x to k plus 1 x dx. From here, I'm going to break down sine x to power n and cosine x to power 2k plus 1 2k plus 1, it's going to be equal. I'm breaking down this exponent. I'm going to put cosine x to power 2k times cosine x, well, to power 1, which I don't put power 1, and dx. All right? So from here, sine x to power n times cosine x squared to power k, I am taking out, and cosine x dx. Okay, from here, this is template I'm working out, okay? So then we will take this ready template and use it. So we will know how to work this type of problems. So sine x to power n times cosine square x, it's going to be 1 minus sine square x, right? Okay, to power k, and times cosine x dx. We are squeezing cosine x under dx, and we are getting d sine x. And once we substitute sine x, we have t sine x equal t, right? Here it is. And dt is equal cosine x dx. So we are getting, this is going to be equal integral t to power n times 1 minus t squared to power k, and we are going to get dt, because cosine x dx, it's the same d sine x, right? Okay. Actually, I don't even know why I put this way. I could keep it just like that, not to confuse cosine x dx, and it's going to be dt. And that's it. This is expression that we will get under integral when we do integration for sine and cosine with some exponent. So let's practice this. Let's see what we're gonna do. Question number 1. We have sine x to power 4 Okay, so since we have at the substitution t is equal sine x, remember we did with this template, t is equal sine x, and dt is equal cosine x dx. So we are getting integral sine x to power 4 cosine x to power 4. We take one cosine and leave it for dx, right? Breaking down 5 into 4 and 1, cosine x dx. And this is equal integral sine x to power 4 cosine square x to power 2, right? This is 4. I break down 2 and 2 because power to power, we're going to multiply, right? 2 times 2. This is 2 times 2, not 2 plus 2. Under no circumstances 2 plus 2 because we have the property we are applying, a to power m to power n, power to power, a is equal m times n. That's why. So 2 times 2. Okay. And we are getting cosine x dx. Okay, as a result, we get sin x to power 4 times 1 minus sin square x squared, right? And d sin x, okay, writing down d sin x, which is going to be equal, I am plugging t to power 4, 1 minus t squared, and dt, right? So let's multiply, and we get t to power 4 minus 2 t to power 6 and plus t to power 8. How did I get this? So look here, 1 minus t squared, this is a minus b squared, right? We open a minus b squared and multiply by t4. Yes? 1 minus t squared, it's going to be 1 minus 2t squared plus t to power 4 and multiply by t to power 4. And that's what we get. And the result is going to be t to 5 over 5 minus 2t to 7 over 7 plus t to 9 over 9 plus c. And if we plug back substitution, we are getting 1/5 sin x to power 5 minus 2 over 7 sin x to power 7 and plus 1 over 9 sin x to power 9 and plus c. Okay, let's do next one, number 2. Okay, this is number 2 already because we solved previously, remember? And this will be number 3. Okie. So let's do integral sin cube dx. So obviously, as you can guess, because since we have only one sign, I'm going to make product of the two signs with degree, right? So same way, t is equal cosine x and dt is equal negative sin x dx. Yes? Okay. Because derivative cosine is negative sine. So we are getting integral sin squared x times sin x, right? Cube breaking down 2 and 1. And dx. This is equal integral sin square x is equal 1 minus cosine square x times sin x and dx. Okay, so from here we are going equal, it's going to be integral 1 minus cosine square x, and this is going to be negative d cosine x, yes? Okay, negative d cosine x. And from here we have negative integral 1 minus t squared, plugging our substitution, and dt. Okay, so where from I got this negative sign? So from here, see, sine x dx. So sine x I squeezed under dx, I got cosine x, right? And because here is dt, because we are substituting cosine x with t, therefore that's the reason I switched to cosine, so I can replace it with dt in this case. And we are getting negative t plus t cubed over 3 plus c. Or bringing back our cosine, we are getting negative cosine x plus cosine cubed x over 3 plus c. Okay, so this is, we explore the case when one of the exponent is odd. Now let's look into the case when both of them, the degrees are even. So let me write down n and m. Let me remind you, in first case, it doesn't have to be both of them, both degrees odd. It can be both, it can be either or degree odd. But now we are looking when both degrees are even. Okay. So in this case, we are going to use the following formulas. That's going to be reducing our degree, even degree going to reduce to odd one. So, and the formulas we are going to use is the following. Cosine square x is equal 1 plus cosine 2x over 2, and sine square x is equal 1 minus cosine 2x over 2. This is what we're going to use. Okay, now let's solve the following problem. Number 4. This is number 4, right? No, number 3. No, 4. This is 3. Let me move this down a little bit. Keep space so it can be seen better. Okay, number 4. We have integral cosine degree 4 and sine degree 2 and dx. Okay, and it's equal integral 1 plus cosine 2x over 2 squared times 1 minus cosine 2x over 2. So first parenthesis is cosine square x, right? To power 2, I put to power 2. And second one is sine square x, right? dx. Okay? This is equal 1 over 8, and we are getting 1 plus cosine 2x minus cosine squared 2x minus cosine cubed 2x and dx. So if just in case if anybody is wondering where from is 1/8 and why not it's 1/4, very simple explanation. These 2 we raise to power 2, right? We get 4, and then 4 times 2 is 8. Very simple case. Okay, and this polynomial of cosine I get doing this 1 plus cosine 2x squared, right? Which will be 1 plus 2 cosine 2x plus cosine squared 2x, because this is a plus b squared, right? Opening a plus b squared. And then we multiply by 1 minus cosine 2x. And if you multiply, combine like terms, and you will get this expression. Okay. So, where are we going from here? Breaking down. There is nothing else to do. It's all we have to do, break down. Integral dx, I don't put 1, plus 1/8. Integral cosine 2x dx minus 1/8 cosine squared 2x dx and minus 1/8 integral cosine cube x 2x dx. All right, so and from here what we are getting, let me this cube write down nicely. Okay, so we are getting 1/8 x, right, plus 1/16. Remember, we have here 2x, which means we need another 2 here, which means we have to divide by 2 also. Look at the previous case I explained. So we are getting integral cosine 2x d 2x, right, minus 1/8 integral cosine squared 2x is going to be 1 plus cosine 4x. I am applying formula for cosine square x over 2 dx and minus 1/8. So breaking down cosine cube, just like we did previous case, sine cube, the same way here. Cosine squared 2x, cosine x dx. From here, 1/8 x plus 1/16 sine 2x, right? Integral of cosine minus 1/16 integral dx. This piece we are opening, separating. 1 plus cosine 4x, right? Yes. Minus 1/64. Where from 64? It's 16 times 4, and that's because of this 4, right? Because we will need to squeeze here 4. That's why we divide by 4, which means 16 times 4. Yes? What do we have? 1/64 integral cosine 4x d 4x. There we go. I'll put like that, 16 and then times 4. Actually, I could put here 4, this color, and here is 4. So that will explain everything. Okay, minus 1/8 integral 1 minus sine squared 2x and cosine we're squeezing under inside, and we are going to get, hold on, here also has to be cosine 2x. Let me rewrite. I just noticed I missed. I'm also master of silly mistake, missing here and there. Okay, so we are getting d sine 2x. Since we have sine 2x, let me put here 2, and here also multiply by 2 in denominator, right? And we are getting, let me fit this. Okay, much better. And we are getting 1 over 8x plus 1 over 16 sine 2x minus 1 over 16 x minus 1 over 64 sine 4x. So this last integral, let me work out real quick. So negative 1 over 16, I'm breaking down. Here will be d sine 2x. I'm doing this one, yeah? And plus 1 over 16. So I'm opening because I have negative in front, right? Plus 1 over 16, and with this negative, it's going to be plus. Going to be sine squared 2x, d sine 2x. Now, from this one, it's clean going to come out sine 2x. Why? Because integral and derivative, two opposite operation, they neutralize or cancel each other, so sine 2x clean comes out. Plus 1 over 16. Now here we are doing substitution, which is going to be sine 2x is our t, and dt, because I have d sine 2x, I'm just write down d sine 2x. I'm not opening, taking through derivative, just keeping like that, because that's what I have, d sine 2x. So 1 over 16, and I will have integral t squared dt. Yes? And from here I'm getting negative 1 over 16 sine 2x plus, so t squared, it's going to be t cubed over 16 times 3, right? And that is going to be negative 1 over 16 sine 2x, and plus t cubed, it's going to be sine cubed 2x over 48. So this piece, I'm making copy and dropping right here. Okay, it doesn't look good. I'll move here. 1 second. I can clean all this. I don't need it anymore, right? We already solved it, we know. So, and to keep it clean, I'm cleaning this drafting. And I can move this piece right here. Okay, and we practically have final answer 1 over 8x plus 1 over 16 sine 2x minus 1 over 16x. Oh, we have like terms practically. It's 16x negative 1 over 16 sine 2x. Okay, what do we have here? First of all, this one and this one canceling each other, And 1 over 8x and negative 1 over 16x are like terms. So if we combine, we will get final answer 1 over 16x, because 1 over 8 minus 1 over 16, it's going to be 1 over 16. 1 over 8 is twice as much as 1 over 16, right? And minus 1 over 64 sine 4x and plus 1 over 48 sine cubed 2x plus c. Let me here also put plus c. And this 16, I don't like it. Let me write down nicely. And I am done. Thank you for watching. I'm done with this type of integral. And in next video, I will do some overview in which case, which method to apply, because it's kind of, I dumped on your shoulders way too much. So I'll just make some template in which case, which way to go, which method to apply. So, and we will be done with this, with indefinite integral. Okay, thank you for watching and see you next video.